Thanks for tuning in. Since I published my first video about MQTT, straight away I received the comments about whether there will be any videos about UNS or Unified Namespace. And of course there will be. And today we'll start slowly by evaluating from architectural point of view what it means, define the criteria for UNS, and then in the next video we'll go into more specifics. Before we jump into Unified Namespace, let's check what happens on the shop floor before Unified Namespace is introduced. What you see here is the shop floor with some machines that are PLC enabled, and you have some systems that are connected to those machines. So in, let's say, less advanced plant, you have only SCADA available, and you have the protocols that you need to support because PLC have different protocols or specifications implemented, and you also need the same support on the SCADA side. Then you decided that you want to have the HMIs installed on the plant, and you also go through the same dilemma that, like, to the PLCs that needs to provide the data to those HMIs, you basically need to also investigate the same protocol support for those HMIs. And the same you need to implement for MES, and the same you need to implement for IoT platform. And there are some protocol translators introduced that could be used also in between IoT platform, but also in between the SCADA or HMIs. It depends on the use case and the latency requirements for the protocols that are used, and bidirectionality, let's say, of the communication that is required between the PLC and the system that it needs to translate from. I saw mostly use cases that the protocol translators are used mostly to translate the data, to extract it out of PLCs. Let me know in the comments that you use the translator in bidirectional communication. It's also interesting to talk through this topic. But commonly what I see is just they are used to extract out the data. And that's basically the setup on the shop floor. Let's assume that two systems, in this case SCADA and MES, want to interact. What needs to be done to do that? In a nutshell, what you need to do is either write or buy some kind of connector. If it's well known MES and SCADA, they will have some connector that you need to purchase additional license for or of some kind, or you need to build your own in case they are not supported. And this basically drives the cost of implementation of integration between those two systems. And the same is applicable for IoT platform. If you want MES to extract data out or introduce bidirectional communication between IoT platform services and MES, you need to write some kind of connector. So commonly it's either using some HTTP endpoints or SQL endpoints, or commonly it's some kind of combination of changes that are required on MES side to expose some information, and then for you to consume this information through the connector. On top of that, there is, if you don't, your primary scenario is not to use protocol translator to translate the data out, basically for the PLCs and the protocol that you have, you need to also connect those PLCs to IoT platform, and either IoT platform itself plays this translator role, which is more and more common these days, that IoT platform is the translator, or there is a translator before them that basically translates the data and moves it to IoT platform. And if we want to strip out every infrastructure source, cost of implementation in a nutshell is basically implementation of all those connectors to connect those systems. And that's basically the cost of implementation of the project that will do that for one plant. So let's assume that you've successfully implemented everything and you've successfully connected the MES to SCADA and MES to IoT platform. Everything works smoothly for one plant, and then management asks to scale it out to the plant number 2. On plant number 2, the reality is that SCADA system is different, and basically what you need to do is you need to implement the MES to SCADA connector one more time for a different SCADA system, And also the set of PLCs is different, so you also need to implement the PLC to IoT connector to connect to IoT platform. And let's assume that we were lucky and MES was the same, and you can reuse the MES to IoT connector, right? And in the end, what we're paying for, if we think about it, is we're paying for payload conversion to interact between the systems and the communication protocol that is used to interact between those two systems. You will ask me that, hey, but to homogenize the protocols on the shop floor, basically we want to use protocol translator. That is true, and that is commonly used approach to introduce protocol translator to basically communicate through, for example, OPC UA across every system that connects to the translator, and PLCs are abstracted away basically from the system through the translator. That's the scenario with, for example, SCADA. If SCADA needs some real-time data, OPC UA and this translation latency is not good for scenarios with latency that is less than 1 second. For other scenarios that can work, but it can work only for device telemetry. As you can see, the translator is only connected to PLCs here in this schema, but MES and SCADA and MES and IoT connector, it's basically still this, we need these connectors because it's what is called transactional data about MES, some downtimes, OE calculations, some production tracking information that is basically something that is transactional and needs to be synchronized between the systems if they require this information. And for that, you need to have some kind of connector to synchronize this data. Those points basically define the list of requirements for unified namespace that I want to outline. One of the requirements is that the information that we gather from all the systems needs to be stored in some kind of hierarchy so that we can flexibly subscribe to the hierarchy. And regarding the subscription, it needs to be also granular subscription or broader subscription. There should be flexibility there on what we actually want to subscribe to. And also, on top of that, the systems need to widely support the protocol that we will be using, communication protocol, so that we will remove this communication burden to convert between different protocols. And the second thing, if you remember the payload conversion that we need to pay for, it needs to be consistent, so that between the systems, we introduce some consistent payload for all the systems interaction so that we can consistently use that across the enterprise and do not pay for services that needs to convert basically data back and forth between the systems. Also, one of the things to consider is the flexibility of the subscription mechanism. For example, in this case, we have two machines. Both of them expose the same set of telemetry, amperage and voltage. But we have, for example, our IoT platform, we have some kind of rule or alert engine that wants to process by some criteria the input information that it receives. And in this case, we grab only specific voltage because we created alert rule for specific voltage value, or we want to subscribe to whole information from the location, for example, to track the output of the machines so that we can put this data into MES. And we have to have this flexibility so that we won't be limited just for the scenario to consume everything, because with a lot of devices and telemetry coming from the shop floor, you can end up with a scenario if you want to consume everything and then filter it out. Basically, all your services will be overloaded with useless data because they do not process it. They just subscribe to it and throw it away. And it will quickly get out of hand and you will be overflowed with the messages that you receive. So how can UNS help with this? The UNS is introduced as a central component of communication between the systems. And you have a UNS as a central component and every system interacts with it. And if you want to implement the unified namespace, basically what you need to do is write connectors to unified namespace of some kind. SCADA connector, MES to UNS connector, and UNS to IoT platform connector. So it gathers all the data in the PLCs report, and I think we're still lacking one connector from the PLCs to the unified namespace. And you basically, after writing those connectors, all the data can be aggregated out in the unified namespace and also consumed out of unified namespace to the system that wants to consume the data out. How unified namespace helps with scaling? Let's assume the same scenario that we have the SCADA system, MES, we implemented everything. Now we need to scale to the second shop floor. We were lucky, as we remember, that MES system is the same. So we can reuse the same MES to UNS connector because MES system is the same, unified namespace is the same. And we also can reuse UNS to IoT platform connector because IoT platform is also the same between two shop floors. The only thing that we need to implement is SCADA to UNS connector, and probably I omitted that we also need to translate the protocols and also connect the PLCs to unified namespace to report consistently to unified namespace. If we want to compare the cost of implementation without unified namespace and with unified namespace with the amount of connectors that we need to write, as you see regarding the payload conversion and communication protocol conversion, we need to do both, right, in each place because we still need to convert to UNS format. And if we will compare without UNS, you need to just connect directly MES to IoT platform, MES to SCADA, PLC to SCADA, PLC to MES, and PLC to IoT. So it's kind of peer connections to specific systems. And you need to basically implement the same amount of connectors, but just to UNS. And initial cost of implementation is the same or even bigger for UNS for the plant. Cost of scaling, though, is a bit different between UNS and non-UNS. So if we remove the things that don't need to be implemented, we'll end up with this picture that without UNS, you need to implement MES to SCADA connector. And you also need to implement PLC to SCADA connection because, again, those are different, and PLC to IoT platform connector. With UNS, you only need to implement SCADA to UNS connection because the rest will be the same with UNS, and you just need to implement also PLC to UNS connection, this protocol conversion that needs to happen with the PLCs that are not supported natively by unified namespace that you want to introduce protocol-wise. This was the summary of unified namespace. I wanted to provide a protocol-less description of unified namespace to just give the basic idea of the initial requirements for unified namespace. And the second goal was to provide you with the idea of comparison of the cost of implementation without UNS and with UNS implementation between different systems inside the plant. Because in the internet, unfortunately, there is misconception that it magically will connect using, for example, Spark Plug B. Unfortunately, most of the systems do not have any kind of connection, and you have to implement it yourself, either to UNS or in case of UNS, the non-UNS implementation, you need to just implement direct connection between the systems or create some kind of connector. Without the scaling across the plants, the UNS basically costs the same implementation, and I'm very curious to learn in the comments from you and from the whole community about the implementation within the plant and where you saw the actual benefits of implementation of UNS. Let's say money-wise, whether the cost versus benefit was some kind of justified. That was my summary. Looking for a feedback. See you in the comments.